The public has recently been exposed to multimedia tablets through the big success, and thus the press coverage, of products like Apple's iPad. But in fact, tablet PCs have been around for quite a long time. The first commercial ones were released almost 10 years ago. Since then, the market has grown, and a lot of manufacturers now make this kind of configuration available in their product line. Let's look at what features customers expect in the tablet PC I will partly design in this demonstration. It must be portable while providing the same performance as a laptop. And the main feature is most certainly its touchscreen. It can replace the keyboard or just hide it, but this is what makes a tablet PC more portable than a laptop and more likely to be carried around. Yet, when a designer creates the design for such a product, he's not easily able to predict how it will behave in real-life situations. Typically, a new product goes through several stages in the design process, including prototyping and physical or virtual testing before being manufactured. If the prototype product does not behave as desired, the designer will need to come up with fixes and the whole process will be repeated. This can lead to a number of iterations and lengthen product development time, resulting in many extra working hours and additional costs. In today's competitive world, getting new ideas to market quickly is a key competitive advantage. designsight from Simulia makes it possible to virtually test a variety of options early in the design process to increase confidence the product will behave as required and allow the designer to easily and quickly explore creative ideas. With that in mind, let's get back to the main subject. A tablet PC, as seen previously, and unlike a regular laptop, is meant to be carried around and used casually. So the way I'm holding it and the way my hands are pressing on it represent specific load cases to be studied if I want the customer to be happy with the product. For example, I need to consider the feel factor of the product linked to its stiffness. A tablet PC, which is a relatively expensive object, would feel cheap to me if it was twisting too much when I do this, or bending too much between my hands when I do this. These real-life load cases become part of the user requirements of the product's behavior and are, among others, translated into performance requirements it needs to satisfy, such as its maximum weight or the maximum load it must be able to withstand. Today, I'm particularly interested in studying one of these loading situations on one part of the product, so I'll be considering the back cover of the tablet PC, and we'll look at how it reacts when I bend it, which is equivalent to holding it still on one side and pulling on the other side. In this demonstration, I'll model this by pulling on 2 of the 4 screw holes, and this will create my simulation model. Additionally, the performance requirements of the product indicate that this part should not deform by more than 7.5 millimeters. We'll see the different steps we need to perform in designsight in order to build such a model and look at the behavior of the part. From there, and still using designsight, I'll be able to explore other design options, like changing the shape of the part, as well as different load cases very quickly and easily, and I will show these scenarios in the demonstration. Ultimately, my goal here is to end up with an improved design that can stand up to real-life usage. For me, it means I can pass a design along to my team with more confidence in its performance and reduce the chance that I have to make design changes later in the process. But first, let's start with the setup of the model using the initial design. Because designsight is a V6 application, all of my data is managed in a central database accessible from any location, so I can quickly find the current version of the tablet PC design. I can visually explore the 3D model and select the part I want to work on. I could consider analyzing the entire assembly, but today I'm just interested in testing its back cover, so I'll just right-click on it and open it. From there, the designsight workbench is just 2 clicks away. I'm given the choice between 3 different types of analyses: stress, thermal, or frequency, so I'll select the stress one. The first thing we can notice is how simple the interface is. The simulation panel will guide us through the steps to be completed before running the simulation. And in case we need help, we can rely on the designsight assistant, which always adapts to the current action I'm doing to provide context-sensitive advice. So let's follow the simulation panel and start with the material definition. In our case, designsight will automatically get the material assigned previously in the part design workbench. I can still review which material has been assigned to be sure it's the one I want to use. One other point we can see is that as the step is completed, a green check mark appears next to it. This will be the case for each step, making it easy to determine where we stand in the model setup. We now need to specify how we're holding the part. In our case, if I select these two faces and hold them still, it should be enough to fix this side of the cover. Now, in order for the shape to bend, I obviously need to pull on the opposite side. So let's select the two remaining holes there and there. The load applied by default doesn't look like what I want, but if I just hover my mouse on the balloon, I'm able to find something more appropriate. Then I just need to define the load value according to the part's performance requirements, which is based on typical customer usage. And that's it. In just a few minutes, I've set up my model and now it's ready for solution. All I need to do is to decide how accurate I want my results to be and whether I want to run my simulation interactively or in the background. The analysis will take just a few more minutes to run on my laptop, but to improve this time or to analyze larger models, designsight makes it easy to submit the job to a high-performance parallel computing cluster. When the solution is complete, I can look at various types of results. By default, the stresses appear, and in red are the areas in my part that might fracture or wear out the most quickly. The good news is that the stress values here show that there is no risk of fracture or premature wear. But what I'm really interested in my case, is how much my part has deformed, as this is what defines its stiffness. I can easily switch from one type of results to another and see that at most, the loaded side of my part will move by 10.6 millimeters. If I want to see where the exact maximum value appears, it's again something I can display pretty quickly in designsight. So here, the value of 10.6 millimeters is way too high, considering that my requirement was to have it less than 7.5 millimeters. In order to reduce deformation and increase the stiffness of my part, I'm naturally thinking about adding stiffening ribs to it. But what shape or pattern should they be? I have created two additional designs, one with a circle-shaped pattern for the ribs, and another one with a cross-shaped pattern. Following the same steps that I described before, I'm able to compare the behavior of the three designs and choose which one fits best with the specifications of my product. Here, the circle-shaped pattern is definitely the most appropriate. The maximum stress is reduced, but more importantly, I've increased the stiffness as requested. The part now moves by 7.38 millimeters instead of 10.6 with my first design, which fulfills my requirement of less than 7.5 millimeters. Now, I need to verify that this new design won't deform too much if I twist it instead of bending it. That means I need to change the type of load I've applied previously. So by interacting directly with my model, I'll just select the previous force to make the balloon appear, and it looks like the type I want to switch to is a torque. Using the robot, I'll reorient the direction in which I twist the part so that it fits with what I have in mind. In about 30 seconds, I've set up a new use case that I can virtually test to see how much it deforms when being twisted, and I see that it reaches a maximum value of 6.6 millimeters, which is still under the limit value in the product specifications. So, using designsight, I've been able to avoid passing on a design to my team that would fail a prototype test by quickly evaluating two alternative ideas. This means I've saved time for me and my colleagues and helped bring our new product to market on time. This ends our demonstration. So, what are the benefits of designsight? First of all, it's easy. We saw that the user experience is self-explanatory and intuitive. Additionally, since designsight is part of the V6 PLM environment, I know that I'm always working on the correct version of my design. Then, it's fast. It took me less than an hour to do all of the design modifications and simulations you have seen in this demonstration. In addition, if I need to, I can reduce the solution time, already quick on a laptop, by using more powerful parallel computing resources, allowing me to try out even more ideas and still help bring the product to market on time. That way, I'm able to understand the real-life behavior of my product without waiting for someone else's feedback or waiting until it's much more difficult and expensive to make changes. And it's integrated. I can design and virtually test my design simultaneously, allowing me to introduce necessary improvements before passing it to someone else. So I am able to try out new ideas, leading to innovative designs. And because designsight uses proven Abacus FEA technology, not only am I confident in my product's performance, but so is the rest of my team. Finally, designsight is part of V6. This means I can manage all my simulation data securely, so I can search, retrieve, and reuse it whenever I need to, and share it with my team, suppliers, or management in collaborative decision-making. If you need further information about designsight, please visit us on the web or contact your local Samulia office.